Then so far we have discussed up to the stack data structure. Then in the face-to-face sessions, we have completed the discussion about stack. Then I will continue from the next topic, that is about queue data structure. Then if you can't hear me, please inform me through a message, right? Because the Zoom is providing the message showing capacity facility, then please send me a message, because don't know whether you can speak with me or not, because when I was scheduling that, I think you can unmute and talk with me. Anyway, we'll continue with the presentation. Then when we take the queue data structure, it is also an abstract structure and similar to stack. The main difference is that it's both ends open. Then out of these two ends, one end is always used to insert data. Inserting data is considered as Enqueue, and the other end is used to remove data. That end, removing data is considered as Dequeue. When we were talking about the stack, it was last in first out data structure. But when it comes to queue, it is first in first out data structure. This first in first out facility operation is possible because both ends of the queue is open. Then the data item stored first will be accessed first. For this data structure, real world examples can be provided. One example is a single lane, one-way road, where the vehicles enter first and exit first. Queues at the ticket windows and bus stops are real-world examples for the queue data structure. Then this can be implemented using the array or the linked list. Then we'll move on to the basic operations of the queue. And the two most basic operations are the Enqueue and the Dequeue. Then in addition to this Enqueue and Dequeue, few more functions are required to make the above mentioned queue operations. Then it gets the element at the front of the queue without removing it. And there's another function called as Isfull, and it will check if the queue is full. Then the next function is empty. It will check if the queue is empty. When we consider the queue, we always dequeue or access data pointed by front pointer, and while enqueuing or storing data in the queue, we take help of rear pointer. Then we can write algorithms for the peak. If we take the algorithm, then we can say begin procedure peak, return queue front. Peak always returns the front element. Then end procedure. Using C and C++ also you can write a function for the peak. Then the next function is full. Then when we consider the algorithm, we can say if rear equals to max size, then return true. Max size is the maximum size. Otherwise, return false. If max size is true, then you can't enqueue elements to the queue. That means it's full. Otherwise, it's not full. Then is empty. If front is less than min or front is greater than rear, then return true, otherwise return false. Then when we are using the queue, we use two pointers with the queue. One is the front and the other one is rear. Then in the stepwise, if we want to enqueue the queue, then first check if the queue is full. If queue is full, then it should generate overflow error and exit. Otherwise, if the queue is not full, increment rear pointer to point the next empty space. Then add element to the queue's location where the rear is pointing, then return success. Then diagrammatically we can show the queue in this manner. I hope that you may have seen this in with printed materials in books or in the internet. Then you can see front pointer and the rear pointer. Now this diagram shows how we can enqueue D. Front is always pointed to the front element. Then rear pointer is pointed to the last element of the queue. Then when we insert, after inserting or enqueuing D, D is at the rear position. Right? This is before entering the element to the queue. This is after entering the element to the queue. Then we'll consider about enqueue. If queue is full, then it should return an overflow message. Otherwise, rear will be get incremented by 1. Then queue's rear will get the data element. After that, return true. If this returns true, that means enqueue has taken place. Then the next operation is dequeue. This is accessing data from the queue from its stored elements. Then access data where front is pointing. Always dequeue is taking place at the front and remove the data after accessing that. Then the algorithm can be given in stepwise manner as well. Then in the step 1, check if the queue is empty. Then if the queue is empty, then it should generate an underflow error or underflow message and exit. Otherwise, queue is not empty. Then access data where front is pointing. Then increment the front pointer which points to the next available data element and returns success. Diagrammatically, we can show the dequeue operation in this manner. Dequeue operation takes place at the front. Always it removes the front element from the queue. Then first diagram shows before removing the element. Then front pointer is pointed to the element A. Then rear pointer is pointed to the element D. Then after taking place the dequeue, front pointer points to the element B, which is located as the next element in the queue. Then rear pointer's position will not change. Then algorithm can be given in this manner. If queue is empty, then return underflow. Then if condition should end up with endif, right? Then if underflow doesn't take place, then data will get data assigns queue front. Front element is taken using data, then front has to be incremented by 1, then return 2, then end the procedure. Right? That's about right. Then if you have any questions, please ask now about the queue. Can someone talk about if you have any questions you can ask, otherwise please tell me, I can move on to the next presentation.
No question.
Aren't you on?
No question.
Okay, right. Then we'll move on to the next presentation. Then this is about the next data structure, that is linked list. Then when considering about the linked list, it is a dynamic data structure. Then the basic, there's a special feature of this. Earlier data structures we could implement using the array, but when considering linked list, it is a group of nodes which will together represent a sequence. Then in the simplest form, each node is composed of a datum and a reference. In other words, the reference is called as a link to the next node in the sequence. Then the structure allows for efficient insertion or removal of elements from any position in the sequence. Then this can be implemented. This linked list data structure can be used to implement other abstract data structures like stack and queue. Then the list elements can easily be inserted or removed without reallocating or reorganization of the entire structure. Then we'll consider about the basic concept associated with the linked list. Then each record or the basic element of the linked list is called as an element or a node. Then field of each node contains the address of the next node, and this is called as the next link or the next pointer. The remaining field is known as the data or the information. There's another terminology used for this is called as the payload. Then head of the list is the first node. Tail of the list refers either to the rest of the list after the head or the last node in. Then we'll move on to the next slide, that is about this is a diagrammatic representation of the linked list, and you can see the head. Always the head is a pointer for the linked list. Then data elements are represented horizontally. Data item is there, then there's a field called as next. Always the next is having the reference to the next node of the linked list. Then the last node is having the reference which is called as a null pointer, is used to denote the last node's next reference in the linked list. Then it doesn't have any references to the next nodes. Then this is a representation of the linear linked list. Then it contains nodes which have an information field as well as a next field which points to the next node in the linked list. Then information can be characters, can be a string or a numeric value can be stored there as the information. Then the information field holds the actual elements of the list. Next address field contains the address of the next node in the list. Then next address is used to access a particular node known as a pointer. The entire linked list is accessed from an external pointer list which points to the first node. The next address field of the last node in the list contains a special value known as null, and this null pointer is used to signal the end of the list. Then we can have empty list or the null list. Then it doesn't contain any records or data in the list. Then this is usually the same as saying that it has 0 nodes. Then such kind of a list, empty list or the null list, can be initialized using the operation called as list assign null. Then there's a specific node called as sentinel node. Then in some implementations, an extra node called as sentinel node or the dummy node is added. There was a small connection problem here anyway. I hope now you can hear me. Can you see the presentation now? Then we'll move on to the types of linked list. Then one type is called as a simple linked list. Then the navigation of items can be done forward only. Then double linked list, items can be navigated forward and backward. Then there's another option called as circular linked list. Last item contains link of the first element as the next, and the first element has a link to the last element as the previous one. In the that means the linked list can be traversed in the circular manner. The main feature of this is last element's reference field. Next field is having the reference to the first element. Then there are some basic operations supported by the linked list. One is called as insertion. It will add an element to the beginning of the list. Then there's another operation called as delete. It will delete an element from the beginning of the list. Right, then we'll consider about the insertion operation, that is adding an element to the linked list. Then there are two nodes. One head is pointed to the first node. Then we want to add a data element in between these two nodes. Then description is given. Imagine that we are inserting a node B, which is a new node between node A, which is at the left, and the node C, which is at the right. Then point B next to C. This is how we are going to insert the new node called as C in between. New node is called as B. Right, then we are going to insert the B in between A and C. Then next node at the left should point to the new node. Right, earlier node A was pointing to node C. Now we want to create a link between these two nodes for the new node. The new node is in the middle of the two. Then the link list will show in this manner. The new node is B, then it is in between. Be taken if the node is being inserted at the beginning of the list. Then while inserting it at the end, the second last node of the list should point to the new node and the new node will point to none. Right? This is how we can insert a new node to the linked list. Then the next operation is deletion. Then first locate the target node to be removed using a search algorithm. Then left node, which is called as the previous node of the target node, should point to the next node of the target node. This will remove the link that was pointed to the target node. Then the code can be considered for removing as target node dot next will direct to the null pointer. Then deleted node can be kept in the memory or can simply deallocate memory and wipe off the target node completely. Right? This is how we can delete a node from the linked list. Then the next operation is reverse operation. It will make the last node to be pointed by the head node and reverse the whole linked list. First, traverse to the end of the list and make it point to its previous node. Diagrammatically, we can show it in this manner, but in using in the online mode, lot of in detail discussions cannot be done. Therefore, I hope that these diagrams will help you to understand the operations of the linked list. Then we are talking about the reverse operation. Then make sure that last node is not the last node and have some temporary node which looks like the head node pointing to the last node, and make all left side nodes point to their previous nodes one by one. Reversing is moving back, right? That is the general idea behind the reverse operation. Except the first node pointed by the head node, all nodes should point to their predecessor, making them their new successor. The first node will point to none. This is how the operation will take place. Then make the head node point to the new first node using the temporary node. This is how you can achieve the reverse operation. Then that's about it. Do you have at least basic idea about the linked list? It's a little bit different from the previous data structures because previous data structures we implemented using the array. Here we are talking about a bit different implementation. Anyway, all these data structures are created in the computer's memory, right? Next, we have to discuss about the implementations of the linked list. Then I will discuss the implementations of the linked list. The implementation is how we can implement a stack using linked list. Right, when we considering about the stack implementation using the linked list, basically we have to consider about the push and pop operations of the list. Then a new node should be inserted at the front of the list. Then it will become the top of the stack. Nodes are removed from the front of the list. Right? If we consider about the stack data structure, then it's having only one open end. Therefore, all the operations should take place from that open end. Then if there's another element, you can see that you don't have to worry about this Java code because I have taken this presentation from a freely available site. Then therefore it's having this Java code, but don't worry much about that. But anyway, for your at your level, you have to write only C and C++ codings. Then anyway, when you are learning about Java in the third semester, you can learn about these things. For the time being, you have to consider only about the diagrammatic representation of this thing, and algorithms will be provided to you in with the presentation. When I'm sending the presentation slides, I will include the algorithms for the using C and C language for the operations of the linked list. Then when implementing the linked list, you have to consider about implementing the stack using the linked list. You have to keep in mind about the features of the stack as well as the features of the linked list. Right? That is the most important point to be discussed. End is denoted using the last node. Then this is very much similar to bounding the thing. Then always top is at the open end. Then items are added from the top and items are removed from the top. Right. When we consider the stack, then stack implementation of the linked list. Now there are 4 nodes in the stack. Right. Then we are trying to remove a node from the stack. That is removing a node is pop. Then we have removed the first node element from the stack. Then top is directed to the next element of the stack. Right, that's it. Actually, that's how you can implement a stack using the linked list. Then the next task is to implement a queue using the linked list. Right, this is how we can implement a queue data structure using the linked list. And we can consider a conceptual queue in this manner: plum, kiwi, and those things elements are there. Then this is the physical queue. Front counter is having 4. There are 2 pointers using for this operation, front and the rear. Then it has the total number of elements of the queue. Right? Then queue is represented using these elements: plum, kiwi, grape, and FIG. Fig is there. Then This is the topmost structure is representing the head structure. Then the other structures are representing the node structure, right? Then the head is always having the counting value of the queue elements. Then we can create the queue in this manner. At the initial state, the count is having 0 elements. Then enqueuing, after enqueuing, count should increase by 1 because there are some. Then after enqueuing the next node, then it will be having 2 nodes in the queue. Then count will get incremented by 1. If we dequeue, that is removing an element from the queue, then earlier we were having only 2 elements in the queue. After removing that, then only 1 element will be remaining in the queue. Right? Then count will get value 1. Right? That is how we can implement these 2 data structures, stack and queue, using the linked list. Right? Then today I have discussed about the queue data structure and the linked list data structure, as well as how we can implement the previously learned 2 data structures using the linked list. Right? If you have any questions, you can ask now. Otherwise, we'll discuss about the tree data structure next day. If you have any questions, please raise your questions now. I'm not aware whether you have heard the question or not. If you have any questions, you can ask. Otherwise, we will wind up. Then shall I ask this question from you, whether now all the modules to have other, like, okay, no problems. I will email you the presentations. Then if you want to raise any questions at this moment, you can ask. Otherwise, we will stop this. Give you 1 or 2 minutes time. If there are no questions, then we'll leave. Right, okay. Then we'll stop the session for today. Then there's only one topic remaining to be discussed, that is about tree data structure. Then hopefully next week or somewhere, I will give you the notification for having the online session. Right, then we'll stop for today. Right, thank